So this is 1.5 practice. I roll through the problems. Generally speaking, I don't actually bust out the calculator, so I highly recommend you have one handy. This is y equals 2 absolute value of x. Goes up pretty steeply, so if this is 1, 2, the slope of this line is 2, the slope of this line I believe is -2, something like that. And it's not 1-to-1 because it does not pass the horizontal line test. One over x does this and this. Good to know this because we'll talk about how the slope is really high here and then there is no slope at 0, and yeah, you got all sorts of things going on. This is a 1-to-1 function because horizontally only hits once, even though these are asymptotes. This is 1 over x squared plus 1. We throw this in there a lot. A lot of people say, oh, there's asymptotes when you set the bottom equals 0. Well, that's x squared. It doesn't actually work. But if you put in 0, you get 1. And then it does this weird little thing. It has asymptotes out here at x equals 0. Might think about domain and range, stuff like that, but we're not into that. This is not 1-to-1 because horizontal line tests. I can put in 1 and -1 to get the same answer out. And this one, recommend graphing, not essential for the understanding of calculus or on the AP test. Let me rephrase that. Not essential for the AP test, but pretty important for calculus. I put questions that involve this question directly. All right, it's not a function because when you go horizontal, you actually hit this. Pardon me, not 1-to-1, it is a function. All these are functions. The question is, are they 1-to-1? All right, onwards. Is it a 1-to-1 function? Does it have an inverse function? Well, I know this is not 1-to-1 because I put in 1 or -1, and I get the same answer out. So this is not 1-to-1. It does have an inverse function. All right, but I'm not going to get into that, so I'm actually going to cross that out. I don't really care. All right. This is 1-to-1 because it's actually an odd function that looks like that. And then ln of x squared. Can I put in 0? I can't. There's no natural log of 0. So I believe this thing's going to do this. And since I can put in a negative number, it's going to do this. That's not 1-to-1. And 2 to the 3 minus x. Throw it in a calculator, graph it. You get something like this. And yes, that's 1-to-1. Now, you might say, hey, I thought whether it's 1-to-1 or not is not a big deal. And I would agree, it is not a big deal. But what is a big deal is knowing how to graph all these. Whether you have to use your calculator or after a while you start to get good at it, is of no consequence to me, but you need to know them one way or another to make your life a lot easier. So here we go with our inverse. Lots of algebra going down here. Strap in and hang on. So y equals 5 minus 4x. Then we switch them. We write x equals 5 minus 4y. Solve that, 4y over 5 minus x divided by 4. So y equals 5 minus x over 4. Therefore, the inverse function is 5 minus x over 4. And you could write it as negative x plus 5. It doesn't really matter. So let's do f of the inverse function. And that would be 5 minus 4 times 5 minus x over 4. Cancel, cancel. And distribute 5 minus 5, negative, negative, we get equals x. Check. Now, you could actually do it the other way. There's really no reason. If you want to, go ahead and prove it yourself, but I'm not going to actually show the algebra. All right, y equals x squared plus 1, x equals y squared plus 1, y equals plus or minus, because I'm putting in the square root, x minus 1. I did skip a step there, so hopefully you're okay with that. So that means that the inverse is plus or minus square root of x minus 1. Let's see what we get when we do the composite. We get plus or minus square root of x minus 1 squared plus 1 equals x minus 1 plus 1 equals x. Check. And you can do that the other way if you want. Again, I'm not going to do it. See if it works both ways. F of x equals x to the 2/3. Y equals x to the 3/2. Whoa, what just happened? Did that to the 3/2, and that to the 3/2. So our inverse f of negative 1 this is going to seem real silly. X to the 3/2 to the 2/3, x, check. Y equals x squared plus 2x plus 1. X equals y squared plus 2x plus 1. This has been set up. Y plus 1 plus or minus square root of x equals y plus 1. So notice I went square root, square root. When I put in the square root, we need a plus or minus. A lot of people ignore that. Do so at your peril. Y equals negative 1 plus or minus square root of x. F of the inverse, I didn't write the inverse. The inverse, negative 1 plus or minus square root of x. Shouldn't have underlined that. Now I got to go back with my OCD and underline all these. No, I don't. All right, plug them in. I think I'll jump and make this plus 1 squared, because that's what it is. Otherwise, plugging it all in is going to be kind of a hassle. Negative 1 plus or minus square root of x. And I was a little nervous for a minute there. And then I realized the negative 1 and 1 will cancel, which is nice. Plus or minus x squared equals x. I suppose I could plug that in for x squared and 2x and it'd get real messy, but I make it a habit of not getting messy. All right, y equals 1 over x third, x equals 1 over y to the third. Multiply both sides by y to the third, divide both sides by x, y equals third root of x. Praying and hoping you're not asking me how come there's no plus or minus on there, because it's a third root. I could write this lots of ways. Let's go with 1 over x to the 1/3. I think that's probably my best bet. f of the inverse of x equals 1 over x to the 1/3 to the third equals 1 over x, which equals x. Very nice. This one's a little tricky. Let's see if I remember. I got my notes in front of me so I can cheat, but let's see if I remember how to do this. X plus 3 over x minus 2. So we go x equals y plus 3 over y minus 2. When in doubt, cross multiply. X, y minus 2x equals y plus 3. Trying to get my y alone, so let's bring it over and bring that one over there. X, y minus y equals 2x plus 3. Factor the y, x minus 1. Y equals 2x plus 3 over x minus 1. The inverse, 2x plus 3 over x minus 1. Sorry about that. Check if we did it. Hopefully I can fit all this in. 2x plus 3 over x minus 1 plus 3. 2x plus 3 over x minus 1 minus 2. 2x plus 3 times x minus 1 over x minus 1. 2x plus 3 minus 2 times x minus 1 over x minus 1. They will cancel. 2x plus 3x minus 3. 2x plus 3 minus 2x plus 2. Neat. Interesting. Like I said, I have my notes next to me, but I've not been paying attention at all. Slick. That's math, baby. Onwards. Graph parametrically. I am going to yank these problems out. They're terrible. Why would I do that? I know why I did that. I want you to practice. All right. Yeah, I guess that's not a bad idea for you to practice. You really feel like skipping them, go right ahead. Interesting. There's y equals x. Let's go with, for f, we're going to go with x equals t, and then y equals 3 to the t. And for the inverse, we just flip them. Why does that say 3? I said t. Weird. Hate it when my brain does not do what my mouth says. So y equals t and x equals 3 to the t. Believe it or not, I actually just figured out that that's how that works. That's how you do an inverse parametrically. I have to go fix my notes. You're right. And that's f of x. I'll just call it f. And we'll put the x in. I'm a stickler for details. Okay, for the function, we'll go with x equals t, y equals ln of t. And for the inverse, we'll go with x equals ln of t, y equals t. This will be the function. This will be the inverse. Cool. log, no log, that means base 10. So for the function, x equals t, y equals log of t, x equals log of t, y equals t. Same graph. F of x, inverse of x. My hand is actually getting tired. All right. For f, x equals t, y equals arcsine. I don't like seeing that negative first. It confuses me, and I don't like that. X equals arcsine of t, y equals t. All right, well, sine does this, arcsine does that, so the other one's going to do this. Stops, it doesn't keep going. There's no arrows at the end of that. So this is f of x, and this is the inverse of x. Whatever, man. Now we're rapidly devolving to the spot where we're doing math for sake of math with no, hey, you're going to have to do this eventually. All right. Wow, now we get to have some fun. So solve, well, just natural log of e to the 0.05 t, natural log of 3. C would want to be a 0.05 t, natural log of 3. T equals natural log of 3 over 0.05, which equals 21.972. What does that mean graphically? Well, e to the 0.05 t is going to go like this, and y equals 3 is going to go like this. So they hit at x equals 21.972. Kill. All right, 2 to the x plus 2 to the negative x. I can just add those, right? I'm confused. Let's go with 2 to the x plus 1 over 2 to the x. No, I don't have the faintest idea what I'm doing. 8 fractions, 2 to the x, 1, 2, 3. Please don't forget to do all of them. Same base, add the exponents, 2x. Yeah, all right, cool, I'm on a roll. Plus cancel 1 equals 5 times 2 to the 10. No, don't do that. 2 to the 2x minus 5 times 2 to the x. Why does it say plus plus? I don't understand that. It's supposed to be a 1. I might need to take a break from these videos, so my brain is definitely going all tapioca. All right, let's do a little u substitution. Let's say that u equals 2 to the x. So this would be u squared minus 5u plus 1 equals 0. U equals, we're going to have to do negative b, 5 plus or minus square root of 21, which is b squared, 25 minus 4, 21 over 2. Wow, this is really hard. All right, well, let's see if I can fit this in. I'm getting out of space here. That means 2 to the x, u, equals 5 plus or minus square root of 21 over 2. I take log base 2 of both sides and do some funky math. I get x equals math log base 2, right? Fraction don't know if you can see it, barely. 5 plus, can't do them both at the same time, 21 over 2, 2.260 minus, so it's like minus 9. Wow, cool, negative 2.260. Negative 2.260, 2.260. Graphically, 2x plus 2 to the negative x. Another mistake in my answer key. And equals 5, y equals 2x plus 2 to the negative x. And there's our two spots. Here's one of them. Here's the other one. X values, of course. Whew. Now, are we ever going to use that? A little bit. Yeah, there's pieces where we have to use this and the graphing and solving with your calculator. But you've got to get really good at algebra. So I don't have a problem giving you all this work to do because you really need to get good at it. E to the ln of y equals e to the 2t plus 4. Y equals e to the 2t plus 4. Notice it says solve for y. A lot of people get mad at me with this. Like, well, I was trying to get a number. No, nobody said anything about number. Ln of y minus 1 over 2 equals x plus ln of x. Y minus 1 over 2 equals e to the x plus ln of x. 2, y equals 2e to the x plus ln of x plus 1. Yeah, we might run into that. I feel like I changed this for some reason. This is e to the x plus ln of x. I could do some damage up here, but I'm just going to leave that. And I could have taken the ln x over and see minus, put it on the bottom with the x there and flip it up. And this is fine. There's nothing wrong with that. It bothers me a little bit, but it's fine. Oh no, and I did it in red instead of blue. Oh, the horror. I'll get my blue back. Draw the graph, determine domain and range. Let's just make sure you know how logarithms work. So +2 should send it right. It's going to send it left. So it's putting the asymptote here. Should go like that. Flipping upside down, moving 2, going up 1. So it's going to do something like this. It does not necessarily go through the origin. All right. But your domain doesn't hit -2, goes all the way to infinity. And your range, -infinity to infinity. This is going to shift this to the right. So your asymptote is here, 1, 2, 3, 4. And we just do this. Actually, this one I know hits at 5 right there, but who cares? Domain is 4 to infinity. Range is -infinity to infinity. And now it says find a formula. Now, this is just me being a little goofy. I don't do this in later units. I give you some problems to work on, but then I shut it down. I don't overdo it. Here I am, because you're coming off the summer and you got a lot to learn. You really got to get on top of all this. I cut some problems out. Nope. That's cool. This reminds me a great deal of something that we will do in November, I believe. 100, 1 plus 2 to the negative x, 100, negative y, put up my y. Okay, let's crisscross applesauce. No, yes. So let's multiply this up here. One moment, please. I did something weird. Yeah, I don't like what I did. So I'm going to try this. I'm going to end up crossing it all out. We'll see. Let's rewrite this as 1 over 2y. So x plus x over 2y equals 100. I should have just left that factored. X times 1 plus 1 over 2y equals 100. Let's divide by x. Let's subtract 1. 1 over 2y equals 100 over x minus 1. Let's go with the common denominator. 1 over 2y equals 100 minus x over x. Let's flippy flop everything, leave the 2 here. So x over 2 times 100 minus x equals y. The inverse is x over 2 times 100 minus x. Now it says to prove it. Well, I'm not sure how much proving I'm going to do here. So let's see what happens. I'm going to change colors here to make it a little easier to read. F of f to negative first of x, 100 over 1 plus 2. I think I'm going to go over and keep it simple. No, it's to the negative x, so negative this would flip. So 2 times 100 minus x over x. Wow, that's horrible. That's really horrible. Equals 100 over, I'm going to common denominator, x. So that became x over x. That x is right there. Plus 2 times 2 is 400. I believe I have a mistake here, but we'll find out in a minute. Minus 2x. Interesting. Minus x. Yeah, that's right. Yeah, let's see what happens. I may end up doing this wrong. Let's see what happens. And if I do, then congrats, you get to fix it. So the x flips up, we get 100x over 400 minus x. And that definitely does not reduce to x. So clearly I've made a mistake somewhere. See if I can find it real quick. If not, we will move on. This 1 minus x over x, 100 minus x over x, 2y, y up there, x up there, 2 times 100 minus x. Well, that looks very much like I did that right. So then it's 2 to the negative x. Yeah, that's where the mistake is. Equals, and I still don't think I'm going to do this right, but let's find out. 1 plus 2 to the negative x. That's 1 over 2 to the x. I just multiplied it. That's really quite pathetic. I know I did this with logarithms last time, but that's okay. Let's slap the negative in on the bottom. So we'll leave the top alone. And we will flip the inside. 2 times x minus 100. Cool. Let's see if I can do anything with that. Equals 100 over 1 plus 2 to the x over 2x minus 200. No, nothing I can do. Yeah, last time I did this with logarithms. All right, see if you can fix it. Prove that the function is its own inverse. F of x. We haven't proved it's an inverse yet. Square root of 1 minus square root of 1 minus x squared. All right, that's weird. 1 minus squared equals square root of 1 minus x squared parentheses equals 1 minus 1 square root of x squared equals x. Kill. And this f of x, 1 over x is x. All right, that's good stuff. Yeah, that'll do for now. Actually, I was going to go back and fix this and prove it, but that's fine. I don't mind leaving mistakes, let you people work them out. Happy mathing.